Parallel world theory. The Oak Ridge National Laboratory in the state of Tennessee, USA, is preparing for a quantum experiment that could have revolutionary results in physics this summer, Parallel Worlds Experiment. Leah Broussard and her team noticed that neutrons in the lab were transformed into protons by breaking down faster than nuclear reactors were created and published. One way to explain this difference is to acknowledge that some neutrons on the table are moving into parallel worlds. Indeed, the concept of parallel worlds takes place in the multiple worlds interpretation of quantum physics. So what are parallel worlds, why is it a faded idea, and how do we experiment to open a parallel world? Let's start with what neutrons are. As I mentioned in the Why the Chernobyl nuclear reactor exploded, neutrons are one of the two particles that make up the nuclei of the atom. The other is proto, and we call these subatomic particles. Neutrons can also turn into protons through radioactive decay. Where does lost neutrons go? As a matter of fact, we know that neutrons produced by breaking down the atom in nuclear reactors turn into protons in 14 minutes 48 seconds. We measured this. On the other hand, we have found that neutrons in the laboratory turn into protons in just 14 minutes and 39 seconds. This may seem like an ordinary event to you. However, 9 seconds is actually a big difference, as the speed of light is 300,000 kilometers per second and the nuclear forces affecting neutrons also act at the speed of light. Physicists also need to explain this difference by doing quantum experiments. For example, according to the interpretation of multiple worlds in quantum physics, or parallel worlds as its popular name, some of the neutrons in the lab may have passed into parallel universes. What are parallel worlds? To understand this, we will already conduct an experiment that opens the parallel universes. However, we need to briefly touch upon the basics of quantum physics to see where the concept of parallel worlds comes from. There are two main interpretations in the quantum world, and we can show them with a simple example. Quantum physics does not know in advance how the particles will make a choice in the future, such as going to the right or left of the road, because physicists are not prophetic. However, quantum physics can calculate the probability of a particle going to the left or right of the path by 100%. In short, the future consists of uncertain possibilities, but we can know these probabilities in advance. The possibilities of how quantum particles like atoms, electrons and neutrons behave in the universe also show us the Schrödinger equation, and then we experiment to see it.
Failed to detect language. Please try again a few moments later. Failed to detect language. Please try again a few moments later.
This is the classic quantum physics interpretation of Niels Bohr, who developed the quantum atom theory. But there are also physicists like Sean Carroll who accept the second interpretation of quantum physics, that is, the interpretation of multiple worlds. They say yes, in this universe the electron is gone from the right, but there is also a universe that goes from the left. This is the concept of parallel worlds and parallel universes. What happens if parallel worlds are? Parallel worlds are universes in which choices we do not make in our universe take place. For example, what happens if I get up at 10:00 today instead of 8 o'clock? I did not smile at the nice boy, but if I threw a smile, would I go out with it? Such possibilities. Normally parallel worlds are completely disconnected from the universe we live in. We are not in the same physical or virtual space as these worlds. In fact, we are not even in the same realm as parallel worlds.